In a previous lesson, we talked about reflection in plane mirrors, and now we're going to get a little bit more focused and talk about curved mirrors. So let's just start with kind of the anatomy of a curved mirror. So every mirror that we're going to talk about in this class that's curved will have a few different points that we want to talk about. First of all, this is the mirror itself right here. And we're going to discuss this imaginary line quite a bit over here, called the principal axis. So that will kind of meet in the middle of the mirror, and the spot where it meets is called the vertex. Now, you might have heard this language in math before, talking about the vertex, because really this mirror can be thought of as a kind of parabola. So if you've heard vertex, you've probably heard it with reference to parabolas, and that's why. So here's a practical application of that concept. In fact, there's a lot of what we do here in this lesson and in subsequent ones on lenses that is really good practical application of the math that you learn that seems like it doesn't have any point. Well, here's the point to it. So every mirror, every curved mirror will have a spot. If it's a good curved mirror, it'll have a spot where all the light rays that are coming in parallel to that principal axis will all reflect to one spot. And that spot right over here that we label F is called the focus. For many curved mirrors, if the curvature is just right, that focus is a point that's exactly halfway between the center of curvature of the mirror, center of curvature of the mirror. So this distance from here to there is the same as the distance from here to there. So the focus is exactly halfway through, or halfway from the center to the vertex. And the reason we call it center of curvature, if I can just show you, you don't need to write this down, if I can show you, I'll just draw a little big circle over here. Let's try to get it so you can see the entire circle. So the mirrors that we're going to be looking at kind of approximate a section of this circle. So if we were to take this, if we were to make this circle out of a reflective material, and we were to just cut out, we'll say, a section from there to there. Well, that section over here would represent our curved mirror. Now, it's not exactly like this. There are some slight changes at the edges of the mirror, but for all intents and purposes, for as far as we're concerned in this course, we can treat that mirror like it's part of a circle. So if it's part of a circle, then there is some center of that circle somewhere over there, and that is our center of curvature. So the smaller the center of curvature, the more, the rounder. You see, if we have a smaller center of curvature over here, then the mirror curves more. So let's get rid of that. And move on to, so those are all the parts that we're talking about. Let's move on to look at the two different types of mirrors that we're going to be talking about. And it's really, what we're really looking at, as I just talked about that circle that we're cutting our mirror out of, the type of mirror is going to be dependent on whether we're looking at the outside of that circle as a reflective surface or the inside. Sometimes the mirrors can be both. Think of a spoon. Think of looking yourself in a spoon. When you're looking at the part of the spoon that you eat from, then you're looking at the inner part of that circle. If you turn the spoon around to the bottom of the spoon, you're looking at the outer part. So when the reflective part is on the inside, and so the non-reflective part, I'll just draw with little lines there to say that it's like fuzzy, that's not the part that we're worried about. then we call this a concave mirror. And again, I believe you've seen this in elementary school. I'm not sure that you've seen this in elementary school before, so it's probably not all that new. I always look at it as a cave. If you go into a cave, so the mouth of the cave will kind of look like a concave mirror. And the other aspect of that, if the outside of the circle is the reflective part, then we call that a convex mirror. Sometimes you could have, as I was mentioning with the spoon, it can be both convex and concave, and so how do you know which one to treat it as? You look at where the object is. So if I have a mirror that looks like this and both sides are reflective, if I put the object on here at this point, then this mirror then becomes a convex mirror because the object is on the side that points out. If I put the object over here, then it becomes a concave mirror because the object is pointing towards the side that points in. So the uses that each one of these mirrors have and what we do with the mirrors really does depend on whether it's concave or convex. Well, we looked at ray diagrams in plane mirrors, and we're going to look at ray diagrams now for curved mirrors. I'm going to show you how to do those both in concave and convex mirrors. And hopefully the goal here is that after we're done this and you draw a bunch of diagrams, you can see what kind of images that you get from these. And based on the kind of images that you get, you can determine what the use is of those particular mirrors. You can do a little research on your own and say, okay, what do we use concave mirrors for? What do we use convex mirrors for? And why do you use each one of those? So I've got a little color-coded rays here. So we're going to draw 3 rays with every one of our ray diagrams. Now remember that we learned about the law of reflection, and it's still true here. The angle of incidence equals angle of reflection. But the goal here is to not use any protractors. All you're going to need is a ruler. And you're not even going to need a ruler part of it. You don't have to measure anything. You just need something that has a straight edge. So we're going to draw 3 different light rays coming out here. Now, where the image is going to be formed, let's say we're looking at the top of this object. So I'm going to take a straight line here. We're going to do the red ray first. Okay, so there's my line's going to come from the top of the object. Anything on the principal axis is going to, all 3 rays would reflect through the principal axis, so we don't need to worry about the bottom. We're just going to worry about the top, and say right like that. And then this line is going to go through the focus. So you got to be really careful when you're drawing this to draw exactly through the focus. Now there might be some times when the lines don't work out exactly just based on the diagram that you have, and that's fine. But you do need to be careful that your lines are going through where they need to go through and that you're taking care to make sure that they do. So in this case, you've got a line coming through here, through the focus. So incoming rays go through F, or through the focus. It reflects parallel to the principal axis. We'll just use PA as a short form. If you're going to forget that, then write it down in full. So it reflects parallel to the principal axis. So let's draw my line here, coming from this point right there, and reflecting parallel to the principal axis, just like that. Okay? So it goes in here and reflects there. Always draw your arrows to show which direction the light rays are moving. So let's look at a second light ray. The second light ray is going to come in, we're going to do the opposite. It's going to come in parallel to the principal axis. So let's draw a blue light ray here. And let's go back one and try to get those leaving from the same spot. There we go. Parallel to the principal axis, you just use your ruler. One of the things I would suggest is measure the height of your object and then bring the ruler over to where the mirror is and measure that exact same height. So you make sure that your line is absolutely parallel to the principal axis. So I might measure this here to be like 6 millimeters, and so I now bring my ruler over here and I measure out 6 millimeters and I put a little dot over there, and then I connect the top of my object to the dot. And so that way we know that the lines are parallel. Okay, so once I've got that done, now I got to figure out where the, I can put my arrow, I got to figure out where it reflects. So this is going to reflect through the focus. So, and you might recall, we're talking about wavelengths and frequencies, and I had you draw the F, and frequency is with a little bit of a tail, a script F. That's because we don't want it to get confused with the focal focus or focal length, which is also an F. So, the line comes in, ray comes in parallel to the principal axis. It will reflect through focus. And I can do this. You can, so I can fix this up there. Okay. So that looks pretty close. Now you'll see there's a point where those two reflected rays, not the incoming rays, but the reflected rays meet. That should be where the image forms. Now, if we drew 1,000 light rays coming from the top of our object and measured the angle of incidence and angle of reflection at the mirror of every one of those light rays, they should all pass through that, all intersect at the same spot. That's where the image is going to be formed. So if that's true, then I should be able to pick any light ray, and the light ray I'm going to pick as a third one that will go through that same point, they all meet at the same point, is the one going through the center of curvature. So remember what we talked about a little bit earlier, that any light ray that goes through the center hits a circle at 90 degrees. So if it's hitting the circle at 90 degrees, it's going right along the normal. So the angle of incidence should be 0, and therefore the angle of reflection is also 0. So let's draw a green ray that represents, let's go with that one. And our green ray will go through the center, hit the mirror, just like that. Perfect. So it goes that way, it hits the mirror and reflects that way. Now notice now that all three light rays, reflected light rays, this little blue one here, and this little red one there, and that little green one there, all three light rays will meet at the same spot, right here. So this is where our image is. That is where the tip of the image that we're going to see. So we're going to draw it right like this, and this is our image. Now all the light rays actually go there. They reflect off the mirror and they actually end up at that spot. So that's going to give us a certain type of image that we're going to talk about in a second. So let me just fill this in at the bottom. Incident rays go through center and reflects through the center as well. So we talked about this image. We can talk about certain characteristics of the image. So let's just jot this down back here. Characteristics. So oftentimes people will talk about SALT characteristics, size, attitude, location, and type. I prefer to talk about SAT, and the location part I think is pretty obvious. Yeah, it's right there. So let's look at what those SAT ones are. So the S is for why am I drawing a blank right now? Size. So it's a comparison of the size of the object and the size of the image. So in this case, the image is smaller. You can go back up and look at the actual image there. It's way smaller than the object. Okay, you could also have larger or the same size. The A is for attitude. Attitude basically means upside down or right side up. Another way of talking about that is inverted or erect. either one of them are fine. I know people probably have a little bit of a giggle with calling the image erect. Go ahead, get it out of your system. That's just what the language is, right? Erect means standing straight up. So in this case, it's an inverted or upside down image. The location, some people use zones. Some people use a description like, oh, between the focus and the center of curvature or whatnot. To me, I think that your location is pretty obvious based on your diagram. So let's look at then the type. And I made reference before a couple minutes ago that all the light rays are actually going to that one spot, which makes this a real image. So a real image is one that you can capture on a screen. So if we were to put a screen at that location, that we could see the image right on that screen. The opposite of that would be virtual or imaginary images. And those in the light rays don't actually come from there. They just look like they're coming from there. Like anything you get in a plane mirror. Remember in the plane mirror video that you should have already watched, we talked about drawing dotted lines because the light rays didn't actually come from there. They just looked like they were coming from there. So when that happens, when where the light rays meet is behind the mirror, so to speak, so the light rays don't actually come from there, they just look like they're coming from there, that's when you get a virtual image. If I look at myself in a plane mirror, I can't put a screen in back of that mirror and have my image show up on that screen. So that means that my image is virtual. So let's take a look then at what this looks like with a convex mirror, because it's very, very similar, but it has some slight differences, and people do tend to have a little bit more trouble with the convex mirror than with the concave mirror. So incoming ray goes towards F. Now, the ray is going to hit the mirror, so we can't draw the incoming ray go through F. That's impossible. It's going to hit the mirror, it's going to reflect. So this is what you do. You draw your object. Let's go back here for a second. So you draw it towards F. Now what you would do is you'd put your ruler down there and make sure it lines up really well with the focus and the tip of your object. And then when you draw your line, you'd have your ruler. So here's my pen. I'm going to draw my line. You just draw it to that point. Take that out. Now I can't do that here. So what I'm actually going to do is I'm just going to put a little dot right over there. Now I'm going to kind of back my line up. Quite like that. Okay, back that line up to that point right there. Let's see how that looks. Yeah, all right. So the light ray is going towards the focus. So you don't draw the light ray on the other side of the mirror actually to the focus because it never actually gets there. So how does it reflect? Now, just like the last time, anything going towards or through the focus will reflect parallel to the principal axis. So let's draw that. Let's draw our light ray reflecting parallel to the principal axis. So something like that. Might be a little bit off there. Let's see if I can move my line. Let's see if I can move my line. There we go. So right about like that. Okay. So light ray comes in and reflects. The second light ray, incoming ray is parallel to the principal axis, so let's draw that one as blue light ray. And we'll start it off in the same spot, and it comes in parallel to the principal axis. Okay, good. Now, it's going to then reflect, and when it reflects, it's going to have something to do with the focus. So anything that's parallel to the principal axis has something to do with the focus. So in this case, we can't make it reflect to the focus because the light ray cannot go through the mirror. But what we can do is have it reflect from the focus. So you would put your ruler down on your page and put one end of the ruler on the focus and draw the other one right through where that first ray hit the mirror. Now, I'm going to overlap this because the light ray never actually goes in this spot right over here. Okay, so I'm just going to draw a little dotted line like that. It's not perfect, but it's close. And shorten this up. So this is what it's going to look like. The light ray is dotted between the focus and the mirror because the reflected light ray never actually gets to that spot. It just looks like it's coming from here. It just looks like it's coming from there. And the same thing, notice that the two reflected light rays, the red one and the blue one, don't actually meet on the side of the mirror where the object is. They're diverging, they're going away from each other. So I can actually do the same kind of just backwards. This line that's coming, that reflected light ray from the red line, looks like it's coming from back here. It looks like it's been going kind of forever from back there. And now you see that those two light rays meet. So let's look at that third ray. So the incoming ray in the blue one is parallel to the principal axis and reflects from the focus. The incident ray going towards C and reflects from C as well. So what does that look like? So again, we're going to start over here. And I'm going to go towards C. I'm going to stop that right there. And the light ray can't go through the mirror, so all of this, this is an imaginary line, so I draw it as a dotted line, and I'm just going to go back to my line here and shorten it up. In theory, go back to my line and shorten it up. There we go. Right about like that. In fact, I can take this and I can stretch it through because the light ray is going to be coming in from the point here. It's going to be coming in towards the mirror. And it's going to reflect back and it's going to keep going in that way. And so it looks like this light ray is coming from the green dotted lines on the right-hand side of that mirror, so behind the mirror. So once again, all three light rays appear to be coming from one spot, and that's the key. They appear to be coming from one spot. The light rays never actually end up at that spot, but it looks like they're coming from that spot, so that's where your image is. Now, I like to make sure that if the light rays are dotted when they meet that point, then we're going to draw our image as being dotted, and that will give us a little hint to the characteristics. So what about our size? Our size is smaller. Again, what about our attitude? Our attitude is right side up or erect. And what about the type? It's usually the part that people have the most trouble with. Now the light rays don't actually come from that point. At no point in time are those light rays ever at where the image is. They just appear to be coming from there. That makes it a virtual or imaginary image because the light rays aren't there. So if I put a screen of some sort, like a piece of paper, at that point, I'm not going to see the image because the light rays are never actually coming from that point. So on the next couple of pages, you have some practice. The first four are kind of straightforward, three different scenarios that you will get. One with a you figure out what types of mirror each one is, and then on the page after that, you have a little bit of a twist to each of them. So attempt those, give those a try, and then see your teacher about finding out how you've done with that.